Hello everyone, myself Prajnayak and my teammates are Vinash Mohan. Our project is diabetes prediction using machine learning and the project is done under the supervision of Mr. Ahmad Haris sir. These are the agendas that are followed during our project. Abstract our project. Diabetes is a chronic disease that affects millions of people worldwide and can lead to serious health complications if left untreated. Early detection and management of diabetes is critical for improving health outcomes, but traditional diagnostic methods are often limited in their accuracy and reliability. Machine learning models have emerged as a promising tool for improving diabetes prediction and management, leveraging the power of data analysis and pattern recognition to identify early warning signs and risk factors. This project aims to develop a machine learning model for the prediction of diabetes. The model will be trained using a dataset consisting of various health parameters of individuals, such as age, BMI, blood pressure, and glucose level. The data will be pre-processed and analyzed to identify relevant features for the prediction of the diabetes. Objective aim of the project. The main aim of the project is to detect diabetes in human beings. Scope of the project. The scope of this project is to detect diabetes in human beings and helps in classifying the affected of the human beings. To classify diabetes, we can use classification algorithms to train the model with train and test data. Introduction of the project. Diabetes is a chronic medical condition that affects millions of people worldwide. It is a disease in which the body is unable to produce or properly use insulin, a hormone that regulates blood sugar level. Early diagnosis and timely treatment are critical in managing diabetes and preventing complications. Machine learning, with its ability to analyze large amount of data and make predictions, can help in the early detection of diabetes. By predicting the risks of diabetes, we hope to assist healthcare professionals in making early diagnosis and implementing preventive measures, ultimately improving patients' outcome. This project aims to develop and evaluate machine learning models for diabetes prediction using a large dataset of patient data. We will explore different machine learning algorithms, including logistic regression, decision tree, and support vector machines and neural network. By comparing their performance, we can select the algorithm which is suitable for the project. These are the literature review we have been going through for doing the project. These are the methodologies that has been implemented and the modules that are used during the project. Module 1, exploratory data analysis. Exploratory data analysis is an essential step in any data science project. The primary goal of EDA is to understand the characteristics of the data and gain insights into potential relationship between variables. In the context of customer churn prediction, EDA can help identify factors that contribute to customer attrition and inform the development of predictive models. These are the steps that are being followed during the EDA process. Second module, model training and evaluation. During the model training, you will use your clean and pre-processed data to fit the machine learning algorithm. The goal of this step is to teach the algorithm how to make prediction on new unseen data. To do this, you will need to split your data into a training set and a validation set. The training set is used to fit the model and the validation set is used to evaluate the model performance during training. This is important to ensure the model does not overfit the training data and generalizes well to new data. You will then select an appropriate machine learning algorithm and train it on the training set. We will also need to choose appropriate hyperparameters for the algorithms, which may involve using techniques such as grid search or random search to find the best combination of the hyperparameters. These are the steps that are continued. The third module, model performance and deployment. If the model's performance is not satisfactory, there are several techniques you can use to improve it. For example, you can try changing the algorithms, adjusting the hyperparameters, or engineering new features. However, it is essential to avoid overfitting the model to the training data, as this can lead to poor generalization performance. But in the conclusion, model training and evaluation are critical steps in developing a diabetes prediction model. It is essential to carefully select appropriate algorithms, split data into training and testing sets, and choose appropriate evaluation metrics to ensure that the model is performing well on unseen data. Implementation. This is the architecture diagram of our project. These are the steps that are involved in data flow. ER diagram of our project. the sequence diagrams for project, collaboration diagram of our project, and these are the testings that have been done on our project, and these are the results of the testing that have been gone get during our project on our project. These are the inputs and output screenshots of our project. In this, we can able to observe the dataset that is used in our project. This is the dataset, and these are the factors that are involved, such as pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, pedigree, age. Here we can consider the outcomes as 0 as non-diabetic cases and 1 output as a diabetic cases. This is the web application screenshot of our project output. Here we can enter the values of the factors that are required to test the diabetes of the patient. By entering all the factors, we can able to determine is the patient is diabetic or non-diabetic. Conclusion: after using all these patient record, we are able to build a machine learning model which is used to accurately predict whether or not the patients in the dataset have diabetes or not. Along with that, we are able to draw some insights from the data via data analysis and by testing and training the model. We can able to predict the diabetes of the patient and can prevent him by taking the preventive measures. These are the web references and the video links that have been used by us for doing the project. Plagiarism report of our project. And these are the references that have been gone through during our project. And the implementation part of the project will be told by my teammate Avinash.
Hello everyone, this is Avinash. Now let us see the implementation part of this project. So here we are seeing the Jupyter notebook, and from starting here we are seeing the dependencies that are imported, such as NumPy, Pandas, sklearn and IMPlearn. Next we are collecting the data collection is done and then analyzed. So here pd.readCSV is the function used to read the data from the CSV file, and here we are printing the head of the dataset using dataset.head function. Here we can see the variables as pregnancies, glucose, blood pressures, skin thickness, insulin, BMI, pedigree, age and outcome. Here outcome 1 represents the presence of diabetes and 0 shows the absence of diabetes. And here we can see the indexation starting from 0 and ending with 767. That in the sense we are having 768 rows and 9 columns. So we are having here outcome as capital O, so we are changing the same as small o, and here we can see the shape, that is 768 rows and 9 columns. Here we are getting the description for analyzing. So here it shows the count, mean, standard deviation, minimum value and maximum value, and different three quartiles, that is 25 percentile and 50 percentile and 75 percentile for all the nine outcomes, 9 dimensions. Here we are getting the number of data that are showing outcome as 0 and showing outcome as 1. So we are printing the mean for different dimension, all the dimensions of outcomes 0 and 1. And we are separating the data set. So here outcome is the dependent variable, and remaining columns are independent variables. So x consists of the independent variables and y consists of the dependent variables. So printing x, we are getting the independent variables as pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, pedigree, and age. And y, we are getting the outcomes. So here data standardization, we are transforming all the data that is present in the dataset into single values, into decimal values. Next, after transforming the data, we are splitting the dataset into test and train dataset datas using the train test split function. X train is consists of independent variables of train data, and X test consists of independent variables of test data. Y train consists of dependent variables of train data, and Y test consists of dependent variables of the test data. Here we are printing the shape. This is the training of data using SVM machine, support vector machine model. After that, we are evaluating using accuracy score. We are getting the accuracy of 0.76 for train data and 0.5775 for the test data. So with the random data, we are testing the model, the classifier, and we are getting the result. In order to save the trained model, we are using a pickle dependency, and we are saving as the trained model.sav. Using that saved model, we are testing the testing with the random data, and we are getting the outcome out. So the model training is done until here. Next comes the web application of the for this model. So here is the code for web application of diabetes prediction. So again, we are importing the same libraries as previously imported, and we are reading the CSV file, which is the data set, and we are separating the columns, and then standardize the data frame. Testing the data is done, and training the data is done, and load the saved data saved model, trained model. So here is the predictive function. So here st.sidebar will give the sidebar and radio button for navigation. We have two pages Data and the diabetes predictor. Data consists of a dataset and the definitions of the variables, and next the diabetes predictor consists of the predictor. So if rad equal to diabetes predictor, if we uh, select the data, then this particular code will be executed. So st.title will showcase the title of that page. So here diabetes prediction dataset is the title, and it writes about the data set, the variables, and it will be the dataset will be printed. And here for diabetes predictor, it will show as the title as diabetes prediction web app, and these are the inputs that will be taken, and after that it will check the with the predicted that saved model, and then the desired output will be shown. Now let us execute this particular thing. Here is the web application which we are seeing, the diabetes prediction. So here is the navigation, and this is the data which we have selected. So here it gives the description of the dataset, and diabetes dataset is shown, and we click this. All the data is shown here. Next, here in the navigation we are pressing diabetes predictor. Here it shows diabetes prediction web app. So now number of pregnancies should be added. So we will add the number of pregnancies as 0, enter, and glucose level 50, enter. Next, blood pressure as 80, skin thickness as 5, insulin level as 50, BMI of a person is 3, enter. Next, pedigree 2, and age of the person as 50. So after selecting this, we'll get that patient is not diabetic. So this is the whole project, diabetes prediction web application using machine learning. Thank you.